So we'll go ahead and find our average rate of change. Remember, average rate of change is just slope between 2 points. So our first point has an x being 5. To figure out your y value, we'll take 5, plug it into your original function, so you get 2 to the 5th. Our second x is x plus 5. So to get our y value, we'll take x plus 5, plug it into our function, and we get 2 raised to the 5 plus h. So our average rate of change is change in y over change in x. So we'll take our first y value minus our second y value. And then we'll take our first x value minus our other x value. So the bottom simplifies down to h. The top we can't really do anything with because they're not like terms. So it says to use your table feature and to graph it. So we're going to pull up our calculator. We're going to put this expression into our y equals. Then we're going to go ahead and look at our table. First of all, you want to go second window, which is your table. You want to make sure that you're on ask over here. Then we'll go second graph and we'll look at table. So now we could go ahead and plug in 0 because that's what we're trying to look at our limit to, but we get an error. And that's because if you plug in 0, you get 0 over 0, which once again is an indeterminate form. So then you can plug in something close to 0. And we want to be really close to 0. And we could keep plugging in stuff that's closer and closer to 0. If you end up plugging in something with too many zeros, and once again this is scientific notation here, it's going to give you a rounding error. So your expression ends up being equal to this right here when you are close to 0. Now we can also go ahead and graph this. If we go back to our calculator, I'm on my basic window, but you may need to go zoom down to 6 before you hit graph to make sure it shows up. We get a little bit of it showing up here. Most of it's all farther above, and we could adjust our window to get it if you wanted. But we could hit trace and type in something close to 0. And you notice you get the same thing that we had before for your output. You'll notice how these values are the exact same. So it can be done either way to be able to approximate your average rate of change when your h is going to 0.